Hello, you're welcome. Today we have this advanced integration problem from G, that is JEE. You understand what I mean? We have to integrate from 0 to infinity the sine of x cubed divided by x cubed dx. Oh my god, this is amazing, right? Okay, so how exactly are we going to tackle this problem? Now, let's begin like this. We're going to define the following function with parameter a. That is, I of a will be equal to the integral from 0 to infinity. The sine of a x cubed, then divided by, oh sorry for that, so divided by x cubed and then dx, right? Okay, that's cool. And we can see that I of 0 is going to be equal to 0, right? Because the sine of 0 is 0. Therefore, everything turns out to be 0. Now, let us differentiate both sides with respect to a. So, the left-hand side, we have I prime of a. So, this is going to be equal to the partial derivative with respect to a of the integral from 0 to infinity of sine of ax cubed divided by x cubed dx, which is same as the integral from 0 to infinity, the partial derivative with respect to a of sine of ax cubed, right? Then divided by x cubed, and then we have our dx. Okay, so from here, I prime of a is going to be equal to, so if you differentiate that numerator sine of ax cubed with respect to a, that is going to give us, remember we have the integral from 0 to infinity, that will give us 3x multiplied by the cosine of ax, then the power reduces to sine of ax squared, and then divided by x cubed dx. So this becomes 3 integral from 0 to infinity. Remember, the x in the numerator cancel the x cubed, reduce it to x squared. So we have cosine of ax, sine squared of ax, then divided by, so this time around we have x squared, and then dx. Okay, so from here we need to make some nice simplifications at the numerator, right? Then we're going to use the idea that the sine of ax squared will be equal to 1 minus cosine of ax squared. So therefore our I prime of a is going to be equal to 3, the integral from 0 to infinity. So cosine of ax into bracket, this will be 1 minus cosine of ax squared, right? Then divided by x to the power of 2 and then dx. So this gives 3 integral from 0 to infinity. So that will be cosine of ax, then minus cosine of ax cubed, right? Then divided by x squared and then dx. So we can still see from here that I prime of 0 is 0, right? Is that true? Because we need something like that here, okay? So we can see from here that I prime of 0 is 0. So let's put it down somewhere. I prime of 0 will be equal to 0, because that will give us the cosine of 0 minus cosine cubed of 0, which is same as 1 minus 1, which is 0. Okay? That's good. Now we're going to take the second derivative on both sides. So the left hand side will be I prime prime of a. So this is going to be equal to the partial derivative with respect to a of 3 multiplied by the integral from 0 to infinity cosine of ax minus cosine cubed of ax, then divided by x squared, then we have our dx. So this is equal to 3. Now if you find the derivative of cosine of ax minus cosine cubed of ax. So I think that is not going to be enough. So let's put something really nice down first, okay? So cosine of ax minus cosine cubed of ax. So no space, x squared. Don't forget our dx somewhere there, okay? So now, finding the derivative, we have I prime prime of a is going to be equal to, so this is giving us 3, integral from 0 to infinity. So the cosine of ax, if we find the derivative with respect to a, that gives negative x sine of ax. That's cool. Okay, we have minus. And don't forget, if you find the derivative of cosine cubed of ax, that will give us negative 3x sine of ax cosine squared of ax. With this negative sign, this becomes plus 3x sine of ax, and then cosine of ax squared. So here we have all over x squared and then dx. Now remember, we have some nice cancellations, right? So I prime prime of a is going to be equal to, this is giving us 3 integral from 0 to infinity. When you split the denominator, when you divide the numerator and the denominator by x, so this is going to reduce this to 3 sine of ax, right? So 3 sine of ax right over here, and this is going to give us plus 3 sine of ax cosine squared of ax, right? Then divided by, so now this reduces to x and then dx. So we use the idea that the cosine squared of x is equal to 1 minus sine squared of x. Is that true? Hope we're not making any silly mistake here. So I think we have to consider where we have the negative signs so that we'll be sure that there is no mistake here. So are we making any mistake? I think we just forgot this negative sign here, okay? So here we have I prime prime of a is equal to 3 integral from 0 to infinity. So this is negative 3 sine of ax. So this is going to be plus 3 sine of ax into bracket. This will be 1 minus sine squared of ax. Then divided by x, and then we have our dx. Okay, so from here we're going to open up this bracket, so we get I prime prime of a will be equal to 3 integral from 0 to infinity. So we have negative 3 sine of ax. So this is going to be plus 3 sine of ax, and then minus 3 sine of ax cubed. That makes sense. Then divided by x, and we have our dx, right? Okay, that's cool. But wait a minute, I think we're making mistakes somewhere. We put something where it's supposed not to be, right? Did you realize that these 3 shouldn't be there? These 3 shouldn't be there. Oh my god, this is very silly of me. And here, these 3 shouldn't be here. Oh, so sorry for that. So we cannot proceed. Now simplifying the numerator properly, we have a prime prime of a is going to be equal to 3 integral from 0 to infinity. So negative sine of ax plus 3 sine of ax is giving us 2 sine of ax. Then minus 3 sine of ax cubed. And then divided by x. And here we have our dx. So I just hope I'm not gonna make any other mistake, because I hate mistakes, right? But it helps us to improve, right? Now we're going to use this identity. We know this sine cubed of ax, with the trigonometric identity is going to be 3 by 4 sine of ax, right? Then minus 1 by 4 sine of 3ax. So using that, we get I prime prime of a is going to be equal to, remember we have negative 3, so it's multiplying everything out. So we have 3 integral from 0 to infinity. We have 2 sine of ax with the negative 3. That's going to give us negative 3 into bracket 3 by 4 sine of ax minus 1 by 4 sine of 3ax. So which is giving us negative 9 over 4 sine of ax, then plus, right, 3 by 4 sine of 3ax. So don't forget, we're dividing everything by x, and we have our dx. So from here, I prime prime of a is going to be equal to 3 integral from 0 to infinity. So here, 2 sine of ax minus 9 over 4 sine of ax is giving us negative 1 by 4 sine of ax. Is that correct? Is that correct? Yeah. So negative 1 by 4 sine of ax right over here. Then plus 3 by 4 sine of 3ax. Then divided by x. And then we have our dx. So we can split the integral now. And that's going to give us I prime prime of a will be equal to negative 3 by 4 integral from 0 to infinity. So we have sine of ax divided by x, right? Then dx, and then plus, that would be 9 by 4. The integral from 0 to infinity. So we have sine of 3ax divided by x, and then dx. So we can see the Drichlet integrals popping up here, right? So for this part here, if you make the substitution, letting ax equals t, and this part here, you make the substitution, letting 3ax equals, let's use v. So everything turns out to be I prime prime of a is going to be equal to, so that's going to be just negative 3 by 4 integral from 0 to infinity. So this will be sine of t divided by t dt. And then plus 9 by 4. The integral from 0 to infinity. This is going to be the sine of v divided by v dv. So I think we're very proud of this integral, right? So I prime prime of a is going to be negative 3 by 4 multiplied by, this is the well-known Drichlet integral, which is equal to pi by 2, and here plus 9 over 4 multiplied by pi by 2. So I prime prime of a is going to be equal to, so simplifying this, this is going to give us negative 3 pi by 8 plus 9 pi by 8, which is giving us, that is going to be 3 pi by 4, right? So 3 pi by 4, yeah. So we need to integrate both sides. So integrate both sides. Okay, so the left-hand side, we have just I prime of a, right? So just I prime of a, which is going to be equal to 3 pi a divided by 4 plus c1. Yeah, that's our c1. So remember that earlier, I prime of 0 is equal to 0. Therefore, here, we're going to let a equal 0. And when you do that, you get 0 at the left-hand side is equal to 3 by 4 times 0 is 0 plus c1, which implies that our c1 equals 0. So we have this true equation that I prime of a is equal to 3 pi by 4a plus 0. That just 3 pi by 4 actually, just like that. Okay, so we integrate both sides again, and at the left hand side here we just have I of a, which is equal to 3 pi multiplied by a squared divided by 2 times 4, that is 8, plus c2. Remember again that I of 0 is equal to 0. Therefore, let a equal 0 here. So we get 0 is equal to a squared dmx everything 0, then plus c2, which also implies again that c of 2 is equal to 0. So therefore, we have this wonderful equation that I of a is equal to 3 pi a squared divided by 8. Now remember that our original integral is integral from 0 to infinity of sine cubed of ax divided by x cubed, where a is equal to 1, right? So this equals this. So you can see this is a very nice generalization, right? Which means that we can let a equals 2, we can let a equals 3, and so on. I'm going to get a nice solution to this problem, okay? So here we know that we're going to let a equals 1. That will give us the original integral. Therefore, we have that I of 1 is equal to the integral from 0 to infinity sine cubed of x divided by x cubed dx, which is equal to 3 pi all over 8. And this is what we have been looking for. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to my channel. Also like, comment, and share.